Hello everybody and welcome to today's webinar. Our topic today is how to manage large models in advanced steel using XRef. My name is Sorin Bularca and I'm Technical Manager at Grytec Asia Pacific. So let's get started. First of all, what is an XRef? Do you know how people used to collaborate in the old days? Well, they were using transparent paper and placed it over other engineers' drawing. When the architect has finished the drawing, the structural engineers use it as an overlay and create their own drawing on transparent paper. And so do the MEP engineers. The XRef is using actually the same concept. XRef allows you to view or reference another drawing file within the file you are working on. As a reference drawing, it cannot be edited, but you can see it, snap to it, draw on top of it, and turn its various layers on and off. Because the reference drawing file is actually another drawing file outside of the main drawing file, it is called an external reference file, or XRef for short. Any drawing file can be an XRef. You can XRef more than one drawing file at one time, and you can even nest multiple XRef inside one of another. So let's see a case study example. We go to Advanced Steel. So I have this model, and we can imagine a case study in which we are in an early phase of a big model. What I want to do, just to show you the idea and the workflow of this XRef method, is I want to split this model in two, and I want to do the split here on this particular grid number 2. So for that, first of all, I want to create the model 1, the first half. I will position myself in an angle so I can delete this half. I will delete also the grids, I don't need them in this case for this example. Okay, delete this beam, these columns. Make sure that everything is deleted, but don't delete the elements that belong to this half of the model. So I delete all these clips here, this plate, beam. Okay. So what we have here, this would be model 1. Before saving this model 1, I will do some other settings. You noticed when I deleted the column, the bolts have automatically adjusted their length. So in order to compensate that, I will increase their length with grip increase length with the thickness of the flange of the column that I just deleted. I didn't measure it before, so I will just input a random value, let's say 10 millimeters. I will do the same for this end. And in this case also I have to delete this plate. In this case I will just check the exact thickness of the plate. So it's 8 millimeters. This means that I have to increase the bolt length with 8 millimeters. Okay, so now I can save this model. Let's save as. Save it in this folder. We call it M1. Okay. Then what we can do, we can continue working on this M1. So we can continue on this left side of the model. We can add new elements, we can add new joints or whatever. For now, I can close this one. Let's open again the source. Okay, and now of course the next step is to create M2, so the other half. This one is easier because I can delete all these elements in one step. Okay, we can leave the grids here, it doesn't affect. Okay, so in the previous, in M1, you notice that I increased the bolt size. Here we delete this plate, also this plate, and with the bolts we have to do an important setting. In order to keep the holes in place, we leave these bolts in their position, in their initial position, but we have this option that we can uncheck this, and they will be unused for numbering, they will be unused for collision check, and they will be unused for lists. So now they are just some dummy elements that are there just to keep the original position of the holes in place for the columns. Okay, let's save this too. So we save it as M2. Okay, so now I have M1, I have M2. Of course, for this one we can continue the modeling, we can extend this this model, adding new elements. And what I can do, if I want to see the position of the M1, I use the XRef. So in insert we have external reference, and it opens this dialog window, or we can just type XRef and it has the same functionality. So now I open this, go to my folder. This one is M2, I want to attach M1. Okay, so we have two types of XRef attaching. We have attachment and overlay. What's the difference between these two? In attachment, the attached model will become part of this drawing, and if other people will open this drawing, they can see the attachment. If I choose overlay, it will be just like an overlay as discussed in the beginning of our webinar. We have here some other settings, for example the insertion point. So if I uncheck this, I can modify the insertion point. I will recommend to have this option checked. Then we can also modify the scale, and we can modify on specific directions, but okay, for this case we just leave it 1 1 1. Okay, now it asks me for an insertion point. If I just press enter, it will be going into the origin. Okay, so now as you can see, if I select this one, it doesn't allow me to do any modification. It's just a reference file, and what I can do is open it from here. So just right click and open the external reference, and it will open automatically the file. Okay, so after I finish adding the new elements, the new joints and the new bolts and welds, and after I define all my assemblies, when I finish with all my work, it's important to remember that I have to finish all the modeling before doing the next step, which is the numbering, sorry. So for this modeling in particular, we do the numbering. For this one, we start with 1 and 1000. Okay, we save it, close it. It prompts me that I did a change in M1, and it needs to be reloaded. I just press yes. the change that I have done is that I did the numbering. So now the elements inside this XRef, now they have a number. What I can do is create an XRef, type XRef, and I can detach it using the detach command. Okay, and now I'm back again to my M2. Let's model this one. Yes, we number this one too. So for this one, to easily trace the elements of this smaller model, we start the numbering from 2000, and the assemblies we can start with 200. This is just an example. Okay, so now both of my models are numbered. Let's save it. What I can do also is create a master model. Let's save it. We go in the folder of our model. Okay, so we call it master model. Save it. Okay, and now if I type XRef, I can attach first M1. Okay, enter. Yes, and then XRef again. M2. Okay. Enter. Another enter. So now in this drawing, I can reference all my smaller models, and I can have all the time. I can have an overview of my project, and an overview of the smaller models that I have. Let's save this one. Okay, let's open M1 and let's try to okay. Next step will be to create the drawings. So for creating the drawings, I recommend to create drawings for each model in particular. So for M1 you create an assembly and the single parts drawing for M1, then from M2 the same. If you want to create a general arrangement drawing, then you can use the XRef. So you can create the general arrangement drawing from master model, or even from this M1. I will attach with an XRef, I will attach M2. Enter, okay. And I will create just an example, general drawing, general arrangement. I will use this style. Scale. Okay. Let's see the result. No? So you see, okay, if I open the drawing, you will see that the model that I had and also the reference model, they are both coming out on the GA drawing, and they also have labels. So the idea is that the GA drawing can be created for X-referenced files. Okay, let's go further. What you can do is you can create also BOM lists for each individual small model, and this will be the workflow for the XRef usage. Going back to our presentation, I just want to emphasize some advantages of using the XRef. So segregation of elements. With XRef you can build drawings with significantly decreasing the drawing file size. Being XRefs, so being referenced, the files they have a smaller megabytes, so we have smaller files. This is easy to understand. Generating drawings without errors. The model is split into smaller ones, so we have the possibility of isolating an error into a smaller model, and we can fix it without affecting the entire model. You can coordinate your work with the work of others by referencing other drawings in your drawing to keep up with the changes being made by other designers, architects, MEP engineers, structural engineers. You can create a master model, a master drawing, as I showed before, from component drawings that may undergo changes as a project develops. You have the ability to transfer data to other projects or clients in discrete chunks. Now I want to show you some tips on how to manage large models in advanced steel. So first, it's important to check the minimal requirements on the Gritech website. As a general rule, the higher the resources of your machine, the better the performance. But this is a general rule for any software. Also, it's important to install the software correctly. So for this, we have an installation guide available on our website. I will show at the end of this slide where you can find all the referenced information. In advanced steel we have the multi-user function, and this is detailed in a multi-user guide, and you can find also this guide on the website on your Advantage account, and it describes the procedure of how to manage a large model using this multi-user function. You can use also the Project Explorer to manage the large models. And I recommend you also to use the switch on and switch off tools, which you can find on the toolbar. And also we have related FAQs on the website, on the Advantage account. I will show you. And of course you can use the XRef method that I showed you. But of course it's up to your decision which method is the most suitable for your project or for your type of projects. I will show you where to find this documentation. So now I am in my Advantage account. If I go to documentation, Advanced Steel, first I have to log into my Advantage account. So for the 2014 version we have a user guide, we have the installation guide, and we have the multi-user guide. Also we have some other guides, joints guides, and other useful guides that I recommend you to check them out. Also the FAQs. So we have an FAQ, how can the speed in modeling and detailing be improved? And we have here some tips that you can use. And another FAQ here, how are large advanced steel models handled? In this one you can you have some information on how to use the Project Explorer. But we have on YouTube we have videos related to this subject. What I also want to show you are some reference work that our clients did using advanced steel for large models. For example, this one is an offshore platform in West Africa. This one are all from our website. This is cracking furnaces in France. It's designed by Hurti Petrochem, Romania. Another interesting project. This one is a cupola roof, and this one is a model, an assembly of a model assembled. We have a stadium, so a very big project in Grenoble. You can see some details. Mitsubishi showroom. This one is a model in Czech Republic. Also, we have a stadium in Romania, in Cluj. And you can see here it was the XRef technology used. So here are the models, the small models, the M's, as we discussed in the case study. And this is the master model. So this is where the smaller, the XRef are all put together. Of course, you can find many other references on the Greitech website. So going back to the presentation, here are some other references. So I want to show you some advantages of using advanced steel. You can reduce project costs and time. You can deliver projects more efficiently. You can automate repetitive tasks. You can reduce manufacturing and site errors. You can easily manage documentations and revisions, and you can improve collaboration with your partners. All of this using one system. So I want to thank you for your time and interest in advanced steel, and I hope I can find you in the future in our next webinars. Have a good day and goodbye.